video, we are going to learn what are the logical equivalence laws that involves the logical operator, conjunction, disjunction, negation, conditional, and biconditional. Now, before moving to the logical equivalence law, we should need to know what do you mean by logical equivalence statement. Suppose we have two compound statements P and Q. We will say that they are logically equivalent means इन दोनों का logically meaning same है if we are getting the same truth values in every case. Now we can move to the logical equivalence laws involving conjunction and disjunction. Conjunction means and operator, disjunction means or operator. So first law क्या है? That is P and true. Suppose we have any proposition P and that is operated with a true statement by taking the conjunction operator. And we need to judge this statement is logically equivalent to what? In this case, we have P proposition. So P proposition can be true or false, and we are operating with the true statement that is always true. Now we are operating P statement with true statement by using conjunction. So P and Q is true when both are true. It means in the first case we are getting a true and in the second case it is false. Logically equivalent statement means truth values are same. So you can observe that in the first column and in third column truth values are same. It means logically these two statements are same, or we can say that P and true is logically equivalent to P statement. Similarly, we can find P or false statement is logically equivalent to what? As P proposition is there, that can be true or false, and we are operating with a false statement. It means it is false in both the cases by disjunction operator, that is P or false statement. So P or false statement is false when both are false, otherwise true. So right now ये statement क्या बनेगी? True in the first case and in the second case it is a false. So you can check it. P or false statement is similar to the P statement as we are getting a same truth values. So we can say that P or false is logically equivalent to P. So this is the first law. We call it as identity law. Now how to remember that this is identity? You can think, suppose we have any statement, if that is operated with the true statement or false by either and or, and we are getting the same result. So identity form is creating. Means P proposition की जो भी identity थी वो as it is हमें identity मिली है over the true statement and false statement. That's why it is called as the identity laws. Let's move to the next law. The next law is P or true statement. It's like we have some statement that is operated with the true statement by using disjunction. So P or true, this is logically equivalent to true. How? If you check it, P is true or false, and we are operating with the true statement. So it means it is true in both the cases. Now operate P or true. So P or true is false only in a one case when both are false. Now both are not false, so it is true as well as this is true. So we can say that this statement P or true, that is tautology, means logically equivalent to T. For the next case, P and false. So let's check it. This is logically equivalent to what? So P is either true or false. We are operating with the false statement, and by using conjunction operator P and false, that is false if any one of them is false, or we can say P and false statement is true when both are true. Both are not true, it means the statement is false. From here we can conclude that P and false statement is always false. And the name of this law is the domination law. Now, how to remember this? When a particular statement is get operated with a true or false by using and or operator, and we are getting the result as true and false, that is called as a domination law. So basically true and false statement are dominating the values of your statement P. That's why it is called as a domination law. But in the previous case true and false dominate नहीं कर पाए P statement को, as it is P statement is there, that's why it is called as a identity law. But जैसे ही true और false ने dominate की है P की value को, that is called as a domination law. Next is P or P, or we can say that P and P. So this is logically equivalent to P statement. अगर आप किसी भी स्टेटमेंट को अपने साथ ही ऑपरेट कर रहे हो, चाहे एंड हो चाहे और हो, एंड वी आर गेटिंग द सेम थिंग, दैट इज कॉल्ड एज अ आइडोपोटेंट. So because of that it is called as a idempotent laws. The same thing is applicable in a matrices when we say a square is equal to a. तो a को ही अपने साथ ऑपरेट किया गया है and as it is we are getting the same thing. That's why it is called as a idempotent matrix. And same thing is applicable here when a particular proposition is get operated with itself by or by and operator and we are getting the same result. रिजल्ट पे कोई इम्पैक्ट नहीं आया है, सेम थिंग इज देयर, दैट इज कॉल्ड एज अ आइडोपोटेंट, ड्यू टू विच इट इज कॉल्ड एज अ आइडोपोटेंट लॉस. नेक्स्ट इज negation of negation P is equal to P, and that is called as double negation law. Why? Because we are using two times negation, so it is called as a double negation law. Next is P or Q. That can be also read it as Q or P. And similarly, if I write P and Q, that can also be written as Q and P. तो आप चाहे स्टेटमेंट को पहले लिखो या बाद में लिखो, मीनिंग सेम है. So logically both the statements are same, and here we are commuting these two propositions and hence it is called as a commutative laws. Next law is P or Q or R. So इसको आप इस तरीके से रीड कर सकते हो, तीन proposition है, in between we are operating or. So either use first two statement to find the result and then use R, or we can say that we can operate first Q or R and then we operate with P. Same concept is applicable over the AND operator. This is like P and Q and R. The name for this one is associative law. Basically, this is similar with the addition and a multiplication. In place of or, we can put addition. That is also written as A plus B plus C. Same thing is applicable with the multiplication. Either multiply the first two terms first, then multiply by C, or you can multiply last two terms, then multiply with the first term. Now the next is P or Q and R. This can be written as P or Q and P or R. So we can distribute P or over the Q and over R. So we can write P or Q, then this operator and P or R. Similarly, we can write in this case that is P and Q or P and R. This is called as the distributive laws. This is similar to the A into B plus C. So you can write A into B plus A into C. So same thing is applicable in this case. Next is negation of P and Q. So we can take negation inside the bracket and we can write negation P negation of and is or negation Q. And in this case, negation P, negation of or is and negation Q. So we have distributed negation over the bracket and it is called as a De Morgan's law. Next is P or negation P. Now a particular statement है P and that can be either true or false. Then negation P is what? Negation P is not of the P statement. Not of the P statement is false and it is true. Now we are operating P or negation P. Remember that with OR operator that statement is false only in a one case when both are false. Right now in the both the cases not both are false. So we can call it as a true statement. Even in this case it is true statement. ये statement कैसी है? It's like a P statement is there. Then we take negation P. अगर P statement true है negation P false होगी और operator में हमें कोई एक statement true चाहिए. So we are done with that. Right now we are getting a one statement as a true P. In the next case if P statement is false obviously negation P true होगी. तो हमें सिर्फ एक ही true चाहिए था and it is there. It means this is logically equivalent to true. Now apply same concept for the next form P and negation P. The statement is true only when both are true. At a time पे दोनों true नहीं हो सकते. If P is true, then negation P is false. If this is false, this is true. So obviously overall we are getting a false result in both the cases when we are using AND operator. So it means this is logically equivalent to false. Now particular statement is get operated with its negation 1. It's like P is there, that is your angel, and the not is its devil. So at a time either angel will win or devil will win. Yes, true. At the same time angel and devil both win. Not possible. It is false. So we are up taking the negative image of itself. So these two logical equivalences is called as negation laws. So this is how you can remember a particular statement that is get operated with its negation 1, hence it is called as a negation law. So basically we have used the three not statement. One is a particular statement with its negation 1, that is called as a negation law. Next is a negation distributed over the bracket, that is called as a De Morgan's law. And when we use negation two times, it is called as a double negation law. Next is P or P and Q. And the next is P and P or Q. तो यहाँ पे ऑपरेटर्स क्या है? डिफरेंट है, बट वन स्टेटमेंट इज सेम. One is inside the bracket and the same statement is outer side. So we need to check this is logically equivalent to what. So right now we have two unique proposition P and Q. Total cases in a truth tables are 4 because two propositions are there. So total number of possible cases in a truth tables are 2 raised to power 2, that is equal to 4. So P proposition is true or false. अगर 4 cases है, half is true and half is false. In the next time take the half of 2, that is 1. So one time true, one time false, one time true, one time false. Now write P and Q. P and Q is true when both are true. That is only in the first case. Otherwise false. Then write P or P and Q. Now we need to operate OR operator with first column and third column. Here we are going to use the OR operator. OR operator is false when both are false. अब check करो both are false where? Both are false? No. Both are false? No. Both are false? Yes. So here we write false. Both are false? Yes. False. So it means these two statements are true. Now check it. This is logically equivalent to what? तो ये column इक्विवेलेंट है टू पी स्टेटमेंट. ट्रू ट्रू, false false. Here we are getting a true true, false false. It means these two statements are logically same. इनका logically meaning same है. So we can write this is logically equivalent to P. Similarly, you can check for the next case. This is logically equivalent to P. And the name of this law is absorption's law. How to remember this? So here P statement observe the value of this. Even in the second case, P observe the value of P or Q. Hence it is called as a absorption's law. So these are the few laws that involve the conjunction and disjunction operator. Next is logically equivalence involving conditional statement. The first and most important one is P implies Q. This is logically equivalent to not P or Q. Let's prove this one by using the truth table. So here we are taking a two proposition P and Q. So total number of possible cases in a truth tables are 4. If there are four possible cases, it means half are true and half are false. So we write two trues, then two false. Now for the Q, we need to write here two times as a true. Now we will write one time as a true, one time as a false, one time as a true, one time as a false. So P implies Q is logically equivalent to what? तो ये कंडीशनल स्टेटमेंट है. द स्टेटमेंट इज फॉल्स ओनली इन अ वन केस व्हेन P इज ट्रू एंड Q इज फॉल्स. तो ओनली इस केस में ये स्टेटमेंट फॉल्स होती है, अदरवाइज ट्रू. सो P इज ट्रू इन फर्स्ट टू केसेस, Q is false in a second case. It means in the second case it is false and the rest one is true. Now we need to move on the right hand side, negation P or Q. So let's take not P statement first. Not of P is it's false, false, true, true. Now write not P or Q. Now here we are using or operator. Or operator false तभी होता है जब both are false. So it means we need to identify where not P is false. That is in these two cases. Identify Q is false in these two cases. That is in a second case. So only in this case this is false. Otherwise true. Also you can take true or false true. True or true is always true. False or true is true. False or false is false. Now check it whether this column and this column result is same. Yes, it means these two statements are logically equivalent. So always remember P implies Q. This is logically equivalent to take the negation of the first statement. This operator is get converted into OR and the next statement is as it is. Next logical equivalence law is P implies Q. This is logically equivalent to negation Q implies negation P. That is called as conditional statement is logically equivalent to its contrapositive. So this is contrapositive of the conditional statement. We have already discussed this concept. The link is given in the description. You guys can check it from there. But we can also prove this one here. So again we take four possible cases in a truth table as we are dealing with the two propositions. So four cases hai. So half is true, half is false. So at a time we have taken two truths. Now we will take at a time one true and one false. P implies Q. This is false only in the one case when P is true and Q is false. तो P कहाँ पे true है? First, second, and Q कहाँ पे false है corresponding to this one? That is only in the second case. So it means rest are true. Now for the right hand side, we need not Q, not P. Not P is these are the two false, then two true. Not Q, alternative of this one. If it is true, then it is false. And if it is false, then it is true. Now we need to take negation Q implies negation P. So this statement is false only in a one case, when negation Q is true and negation P is false. Means hypothesis is true and condition is false. Hypothesis is given in this column. Identify where this is true in the case number 2 and 4. Now negation P is false, corresponding to this one is only in the case number 2. So here we write false and rest are true. Now check whether this column and this column is same. Yes, it means logically they are equivalent. Similarly, there are more four results, that is P or Q. This is logically equivalent to negation P implies Q, and P and Q is logically equivalent to negation of P implies negation Q. Negation of P implies Q. This is logically equivalent to P and negation Q. And when we say P is implying to Q and P is implying to R, so we say P is implying to Q and R both. The main result in the conditional statement is this. So always remember, when you need to break P implies Q in terms of or and, we always write negation P or Q, not of the first statement or second statement as it is. Next is logically equivalence involving biconditional statement. So biconditional statement means if and only if. So we know that when we write this format, it means P is implying to Q and Q is implying to P. So we can write this one in form of logical equivalence. Moreover, we can write P if and only if Q means if not P is not there. So similarly, this is implying to the not Q and not Q is implying to the not P. Hence, we are using biconditional. Moreover, we can write this is logically equivalent to P and Q or negation P and negation Q. Last but not the least, negation of biconditional statement is logically equivalent to first proposition is as it is, biconditional with not of Q. Based on the logical equivalence laws, we can prove multiple statements that they are logically equivalent or not. The first example is show that P and Q, that implies P or Q is tautology by developing a series of logical equivalences. So one way to show that this is tautology is truth table. Second is with the help of logical equivalence laws. As per this question, this is clearly mentioned that we need to go with the logical equivalence laws. Now, how to attempt this question? It's a very simple. First, read the question. As per the question, we need to show that this is P and Q implies P or Q. We need to show that this is tautology. If it is a tautology, means this statement is logically equivalent to true. So we need to prove this one. So obviously in this case we start from the left side rather than from the right side. So I'm taking the left side. P and Q implies P or Q. This is logically equivalent to what? So whenever we have any compound proposition, the first step is always break this conditional statement. Means we need to remove first conditional statement. And for that we have one result, that P implies Q. This is logically equivalent to negation of the first statement P or second statement as it is. We will apply this equivalence over here. So we can write negation of first proposition. This symbol is get converted into or, and second proposition as it is. After this, then you can take negation inside the bracket, because from here we don't have anything. So when I take the negation inside, it is negation of P, negation of and is or, then negation of Q or Now the point is, do we need to keep this bracket or not? Bracket is very very important. So we can eliminate the bracket, or we can say we can remove the bracket if the next operator is same. Like in this case, when we have taken negation inside, we are getting OR and its next operator is OR. So we can remove this bracket. Same thing is applicable in this case. Previous operator is OR. Here we have again OR operator. So we can remove this bracket. Now when we have taken negation inside, there is a particular name for this law. Negation is distributed over the bracket. It is called as De Morgan's law. So we have used here as De Morgan's law. Now what to do in the next step? You can observe that negation P or negation Q does not give any simplification result. Even from P or Q, we are not getting a simplified form. But if we swap these two one, then we can operate negation P or P as well as negation Q or Q. We can directly swap this one because the operators are same. It's like first statement or second statement or third statement or fourth statement. So we can deal either first to one or first third one or first fourth one. There are many ways to simplify this one. But we need to take the liking terms. Means here we have a P proposition. Even here we have a P proposition. Operators are same. So first we will use the commutative law and we swap these two propositions. And it is by the commutative law. Now we can write negation P or P. That is logically equivalent to what? So remember negation P or P. It's like devil or angel. So obviously one will win. So it means true. Keep this operator as it is. Then negation Q or Q. It's same form devil or angel. So this is also true. Now what type of law we have used here? So a particular thing with its negation one. So it is called as negation law. So we have used here as a negation law. This is further logically equivalent to true or true. That is always true statement, which is our right hand side. Hence we have proved that this compound proposition is logically equivalent to true, or we can say that this compound proposition is tautology. Let's take another example. We need to show that this compound proposition is tautology. Now in this case, it is not mentioned whether you need to go with the logical equivalence law or the truth table. So right now I am dealing this question with the help of logical equivalence law, but you guys can try with the truth table as well. So let's start with the same thing. What we need to prove? We need to prove negation P and P or Q. This implies Q is logically equivalent to true. So we start from the left side, that is negation P and P or Q. This implies to the Q. This is logically equivalent to what? Now the first step is always break the conditional statement. So for that we take negation of first statement and implies is get converted into or second statement as it is. And there is no name for this logical equivalence law. This is further logically equivalent to what? Take negation inside because it is like negation over this bracket. First we will simplify this. So it is a negation of negation P, negation of and is or, then negation over this bracket, that is negation of P or Q. Now the point is, do we need to keep the bracket? As we have previous operator is or, and in this case again or, so we can eliminate this bracket right now. So we can directly write or q here. Now what type of law we have used? We have taken negation inside the bracket, or we can say negation is distributed over the bracket. So from distributive D, and D stands for the De Morgan's law. So we can remember by this we have applied in this case as the De Morgan's law. Now this is logically equivalent to what? Negation of negation P, that is P, and we used in this case as a double negation law. This or operator is as it is. Now take negation inside. So when we take negation inside, we have negation P, or is get converted into and negation Q or Q. So we have taken negation inside. Again we have used the De Morgan's law, and in this step we have used basically two laws. One is De Morgan's and second is a double negation law. In the next step, either we take first two statements or the last two statement. It is up to you. Right now I am taking the first two statement and I am going to use the distributive law. Why? Because here we have or and here we have and. So we need to distribute or over the and operator. So we can write the statement as P or negation P, and I need to put the bracket as well because the next time the operator is and P or negation Q. Also keep the bracket because the next operator is or, and here we have and. So in this step we have used the distributive law. We have distributed P or Q over negation P. This operator is as it is, P or negation Q. This is further logically equivalent to what? P or negation P. Angel or devil. Obviously one will win, so hence it is true. This operator is as it is, P or negation Q as it is. Put the bracket because the operators are different. Even keep this curly braces because the next operator is again different from here, and we have used in this case as a negation law. Now this is logically equivalent to what? True and some statement. So it's like a true and there is a particular statement capital P. This is logically equivalent to what? Whether this is always true, always false, or it depends upon P. So obviously it depends upon P. Why? If P is true, answer is true. If P is false, answer is false. It means whatever the value of P we have, the same result we will get. Same thing we can apply here. So true and statement. Answer is the statement P or negation Q. Do I need to keep the bracket? Here we have used or, here is again or. So we can eliminate the bracket and we can write or Q. Now what type of law we have used here? True and statement is equal to the statement. It's like identity. When we are operating a particular statement over the true statement or false statement, but we are getting a as it is result. Hence it is called as identity law. Now this is logically equivalent to what? Negation Q or Q. This is again like devil or angel. So this statement is always true because one of them will win. So P or true. And the name of this law is negation law. Now P or true statement. This is always logically equivalent to true because if P is true, answer is true. If P is false, still answer is true. And here we have used the domination law. because true statement dominates the value of original statement P, and hence the proof is there. So this is how we need to prove the statement by using the logical equivalence law. The first step is always try to break the conditional statement by using P implies Q, that is logically equivalent to negation of the first statement, or Q. Then try to take the negation inside, and after that try to simplify that by distributive law or the negations law.